Atrazine is selective. It tends to be more active on broadleaf plants than it is on grass plants. The first, I'll call it residual, pre-emergent herbicide that you would apply to the soil to control a weed before the weed germinated would have been atrazine. And atrazine became the most widely used herbicide across the Corn Belt shortly thereafter. And probably isn't the most widely used herbicide right now, but it certainly was through the 60s, 70s, 80s, and 90s. Now, in contrast to 2,4-D, the reason that atrazine doesn't kill a corn plant is not anything to do with the structure of the corn plant, but it's the fact that the corn plant has a biochemical pathway that allows it to detoxify atrazine extremely rapidly. It can corn plants can detoxify 10, 20 times the normal use rate of atrazine. They just have, if you will, excess capacity to detoxify, and most broadleaf plants don't have that same pathway, so they simply can't get rid of the toxin. And a lot of times an herbicide would first come out and we would discover that it had potential for controlling weeds and not injuring the crop, but without fully understanding how or why it didn't injure the crop. Now we knew what, but not why. In other words, you treat the crop and the weeds, and the what is it killed the weeds, it didn't hurt the crop, but why, that's a slower process to figure out why that happened. But to accompany that, before any of these products were introduced to the market, a standard set of toxicology experiments had to be conducted to make sure that they didn't result in a risk to the ultimate consumer. Again, we might not know why the atrazine would not be found in the corn plant. We know it wasn't there, but we don't know why. Later we found out that the plant was able to degrade it. So it's like everything else. We find out what usually before we find out why. Two things have been an issue with atrazine. Some cases we find it in surface water. And it's not hard to think of how it comes in surface water. If you use atrazine on sloping land, very sloping land, and you think about when we use it. We plant corn in the spring. If you prepare a seed bed, there's no cover on the land. We tend, especially in the central U.S., to get strong thunderstorms, high intensity rains, which results in runoff. And so on sloping land, if a high percentage of the land is cultivated, clean cultivated, and a high percentage of the land is treated with atrazine, we're applying the material during that window in the spring when we have the risk of these high intensity storms, which are the biggest contributor to runoff. So many other compounds we use would also have runoff under those circumstances, but the reason atrazine was found more widely and in higher concentration is it was used so widely. It's used on 80% of the corn in Nebraska. We don't have any other compound that was used anywhere near that extensively. Now, since that issue has been identified as a problem, there are regulations in place regarding atrazine use on sloping or steeply sloping land, because if you don't have a topography that causes runoff, obviously you don't have a serious runoff issue. Atrazine has been found in groundwater. And by groundwater, I mean water that you might extract from a well. And there's a lot of debate, but pretty good evidence at this point that most of the groundwater contamination comes from using atrazine. And two things happen. Either using it in an environmentally sensitive site. By that I mean where the water table is fairly shallow, 10, 12, 15 feet from the surface, and you have sandy soil above. Water and atrazine are going to move through sand more readily than they do through a clay loam soil. The other place, and it's been a significant contribution to groundwater contamination, is so-called point source. By point source, I mean somehow it seeped into a well or some other conduit directly to the water table. And it has a lifespan in the soil. Our normal figure is the half-life would range, perhaps 35 or 40 days. And so it doesn't degrade so rapidly that it's gone even on the sand. It could get the water table before it degrades. So its longevity and its mobility, along with its widespread use, contributed to that being found in the water table.